Hello students, welcome to my YouTube channels. Today we are going to discuss the one support reactions where the UVL the given, uniformly varying load the given. So like these questions you will always expect in the competitive exams or GATE exam, university exam. So if you know the basic concept, little more bigger problem also you can solve very simple way. So here I taken two UVL, uniformly varying load, also known as triangular load or one point load is there. So AB is the beam where two UVL and one point load is there. So we have to find the support reactions point A and point B. So how to proceed you see here. So before the solving I will discuss the basic concept for completing this solution. So now suppose the hinge support will be there. If hinge support will be there, this is the symbol of the hinge support. Here two reactions will be there. Here to suppose this point A, so two reactions will come, vertical force and horizontal force will be there. And horizontal force will act. Suppose this roller support, what is given here, roller support. Roller support symbols will be like this. Roller support. Roller support only, suppose this point is B, so only VB will be there. Only VB will be there. Suppose fixed end will be there. Suppose this end is fixed. So here three reaction force will be there. VA, HA horizontal and one moment MA. So these three concepts always you have to remember. So three type of support will be there. Hinge support, roller support and another is fixed support. Fixed support means three reactions, vertical, horizontal, moment. Roller support only vertical and hinge support horizontal and vertical. This one concept. Now UVL. UVL, how will see this load diagram if we draw? How will draw the load diagram for the UVL? You see here. So suppose this diagram will be like this. Now this A to C. A to C. This they given 3 meter, this UVL they given 12 kilonewton per meter. Kilonewton per meter they given. If we draw the load diagram, you see here. If we draw the load diagram, we'll convert into point load. How we'll do this? So before this, already a lot of video I discussed. We have to reach the center of gravity point, and load is nothing but 1 by 2 into base into height. Base is 3, height is 12. So this is called area of the triangle. Also that's why this UVL uniformly varying load. Uniformly varying load. This is also known as uniformly varying load, or also known as triangular load. Also known as triangular load. So uniformly varying load, also known as triangular load. So how to convert load? That is called area of the triangle, 1 by 2 into base into height. Then what is the center of gravity point? Center of gravity point always will be the 2h by 3 and h by 3. If you will add these two, it will come h. So how to remember? So which side 2h by 3, which side will be h by 3. So lower sections always will go the 2h by 3 and bigger sections always will go the h by 3. Now look how we'll know this. If you substitute 3 in this h, or here b, because base you are taking na b, you take b. Base height na 2h by 3, h by 3. So 2 into b, 3 by 3. So it is 2 meter. Coming 2 meter. If you see here b by 3, 3 by 3, 1 meter. So now you differentiate this. This is 1, this is 2 meter. That means center of gravity point will be somewhere here. Somewhere here. If you will see from the top, this height h na 2h by 3. 2h by 3. If you will see from the base, here, you can say this from the base this point to here. This is the interrogative point. From this, suppose from here you are coming at this point, this point. From top you are coming at this distance and this distance. 2h by 3, this is h by 3. Suppose this height will be somewhere, suppose you take height is 4 or 6 you take. 2 into 6 by 3. What is coming? 4. So this distance is 4, this distance is 6 by 3, not 2. So that means what you are seeing here, lower sections 2h by 3, broader sections h by 3. Lower sections 2 by 3, broader sections b by 3. So this is the center of gravity point. Then point load I told you now. Now see here. This is 2 meter, this is 1 meter. Now point load where will act? This will act here. What is the load here? 6. So 18 kilonewton now. 18 kilonewton. 12 kilonewton meter into meter kilonewton. So 18 kilonewton. What is the distance? 1 meter. This is distance is 2 meter. This is point A. This is C. So load diagram. So now I will draw the load diagram here. See here 3 meter. So for this load diagrams will be how it will be. So this load diagram will be 1 by 2 into 3 into 12 is nothing but 18 kilonewton. This is load. Then this distance is 1 meter. This distance is 2 meter. This distance is 2 meter. This distance is 1 meter. So one load diagram is over. Now here reactions. If you see this here reactions, what are the reactions? VA. Then here HA. So I am drawing the load diagram from this. So this load diagram is over. Similarly, this point load already here na, you will write now point load what is 20 kilonewton as it is. Point load. Now see this C and B, one other UVL is there. C and B, another UVL is there. So suppose you will draw again like this diagram will be there. Now you know from this side we have to see, or this side you have to see. Where from where? So from this side if you will see na, this suppose B to B by 3. So this distance will come somewhere here. And this side will see the B by 3. Now from top we'll see, suppose this H to H by 3. So somewhere you will reach here. So this is called CG point. This distance is 2H by 3. From here, 2H by 3. And from here again you will see na H by 3. So this distance, H by 3. So this is CG point. So that means what we are seeing here, 6 is there. If you substitute 6, 2 into 6 by 3, 4. So that means 4 and 2. Here 6 by 3 na 2. So 4 by 3. So now what is the load diagram? This for point load for UVL. Point load of UVL 1 by 2 into 6 into 10. So that means 5, 6, 30 kilonewton. What is this 30 kilonewton here? 30 kilonewton load. Then what is the distance? Man, this part we have to concentrate. So this is vertical load only will be there na, VB. Then this distance will be 4 meter. 4 meter. This distance will be 2 meter. This only we have to know. This only we have to know. Suppose load diagrams is there. Now point load all converted into point load. We'll find the two equilibrium equations. Sigma F equal to 0 and moment about any point will be 0. We'll get the solution. So this is the basic you have to remember here. Basic you have to remember here. First, hinge support 2 reaction. Roller only 1 reaction. Fixed end 3 reaction. What is the area of the triangle? This is the load. How we'll see the load diagram? What is the distance? If you are seeing the lower sections, 2b by 3. So it's coming 2 meter, from this side 1 meter. From this side you are going now 2b by 3. 2b by 3 lower section. So it is coming. So lower sections we are coming now here. Lower sections. Lower sections will be 2b by 3. How we did this? Lower sections will be 2b by 3. So this diagram will be 4. This lower sections will be, this distance will be 4 meter. And this distance will be 2 meter. And this is the load here. What is load? 1 by 2 into 6 into 10. That means 30 kilonewton. This is called 30 kilonewton. This is the load. So listen here. What we did that mistake here. So lower sections will be 2h by 3. 2h by 3 coming 4. So this is lower section this side. This side lower sections 2. This is total 6. So 6, 4 plus 2, 6. So now load diagrams over. So this only, these two you have to remember. Lower sections always 2 by 3. Lower sections always 2 by 3. So this is 4, this is 2. What we will wrote here. So okay, now it is correct. So these things I will rub it now. Now I will solve the question. So what we discuss now, this is all the basic concept for this. Basic concept of this. Now we will solve the question. So load diagrams over now. So this point is A, this point is C, this point is B, and these two load diagram here. So now you see two equilibrium equations will apply. Sigma FH equal to 0. That means total horizontal forces, that is called total leftward force equal to total rightward force will be equal. So what is there? Only one, HA. HA is equal to 0. So no other horizontal force, HA is equal to 0 over. Now sigma FB equal to 0. That means total upward force equal to total downward force. This we will take here. Total upward force equal to total downward force. What is upward force here? VA. And what is here plus VB? Upward force. Now any upward force is there? No. Here only VA upward force, VB upward force. Now downward force 18. Plus this point load 20 plus 30. So this is the second equation. So how much is coming? 68 kilonewton. Coming 68 kilonewton. Now we will take the third equilibrium equations. Moment about A equal to 0. So what we will see here? We will take here total clockwise. Total clockwise is equal to total anti-clockwise moment. We will see here. So A point is fixed. A point is fixed. We are taking moment about A. So BA and HA passing through the same point A. So moment will be 0. As you know, moment is nothing but force into perpendicular distance. Force into perpendicular distance. So see this rotation from A point, these rotations will be clockwise. 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 VB rotations will be anti-clockwise. VB rotations will be anti-clockwise. So what we are write here, total clockwise is equal to total anti-clockwise. Look here, what is clockwise? Force into perpendicular distance. This is called moment. Force into perpendicular distance. So see this point fixed, this rotate. This rotate what is? Clockwise. This rotate clockwise. This rotate clockwise. Due to this rotate anti-clockwise. So clockwise you write here. 18 into distance 1 plus 20 into total distance 3. 20 into total distance 3. Then plus 30 into total distance 7. 30 equal to VB into total distance 9. Total equal to 9. So this is the equations we got. This is the equations we got. So now we will solve this. We will get the answer. So 18, how much is coming? You see here, 18 plus 60 plus 210 is equal to VB into 9. If we will find out VB is equal to, this will come 210 plus 270, 80, 288. 288 divided by 9. If we will calculate this, it's coming 36 kilonewton. It's coming 36 kilonewton. If now you substitute here, suppose you give this equations number 1. If you are substituting this equations 1, so we will write here substituting VB in equation 1. So what will come? VA is equal to 68 minus 36. 68 minus 36 is coming 30. 68 minus 32. This will come 32. 288. Once we'll check this. How much coming? 288 divided by 9. 288 divided by 9 is coming 32, correct. So this coming 32 kilonewton. So if we divide 32, it is come 36 kilonewton. So VA coming how much? 36 kilonewton, and VB will be 32 kilonewton. So this highlight this answer. So this is the VA and this is the VB. The VA. This is the VB. This is nothing but VB. This is nothing but VA. So this way, suppose you know the point load. Suppose you know this point load, converting this uniformly varying load into load diagram, then very simple steps. So that concept you have to remember. So okay, friends, watch this video, subscribe the channel, share these things to your friends so they can get the benefit. Okay, thank you.